So today we will see activity selection problem, which is one of the problem statement we can solve by greedy algorithm. So here what happens, like if we just take an example that would make our idea much clear. For an example, we are having few numbers like 2, 3, 1, 4, 5, 8. So why I'm grouping these numbers, I will say that 16. So the first number say or talks about like starting point of an activity. So ST, start time, and another one is the end T, ET. So this is all about a story of ST and ET. Okay. So in this case, ST is 2, ET is 3. In this case, ST is 1, ET is 4. And that is definite that your AT is going to be greater than ST. That's absolutely because some action is happening and existence of action says that you will have an end time greater than the start time. That's perfectly fine. But suppose one machine is performing this list of activities and the nature of the machine is that it can perform these activities but one at a time. That means it's a single tasking machine. So whenever we are having an overlapping, for an example, the first two tasks, if we just consider like 2, 3 and, or you can say like, you can take this color, 2, 3 and 1, 4. Can you say like 2, 3 and 1, 4? So it got an overlap, right? 2, 3 and 1, 4 is got an overlap. So the machine either can take this one or it can pick this one, right? Because it cannot perform more than one task at a time. Similarly, if we just see the next two tasks, 5, 8 and 5, 8 and 6. So if it is 5, 8, 6, 10, they have an overlapping. So the machine also will take, sorry for the inconvenience, any one of them. So if I say like it an action A2, if I say like it's an action A1, so whichever action has been picked by the machine, then the machine can take maximum 2 tasks. Am I right? Right? So the output of your problem should be 2. So it is not possible to take more than 2 activities on this single tasking machine. Understand? So this is one important statement or explanation which the problem is asking from us, right? Now, if we just go to the approach which we can take. So let's take, let's clear this one. We understand. Now, say for example, we have few numbers, okay? So starting point is 3, ending point is 8. Just a minute, I have this line. Okay. Another activity, say for example, we have 2 and we have 4. Another activity we have, say for example, 1 and 3, right? Another activity we are having, say for example, 10 and 11. So this is the input array or list which has been given to us. And here 3 stands for start time, 8 stands for end time. Similarly, 2 stands for start time, 4 stands for end time of that activity. Now, if we just ask the same problem that how many activities or maximum number of activities that can be performed on this single tasking machine, then what should be our approach? So first of all, I would like to say the basic assumption always remember in this type of problem that we will pick the action which is having less time. Okay. So that means we need to change the input array and feed it in a different way to our algorithm. So now what would be the basis of changing or tweaking this input array? The simple thing is, as our assumption is to pick up the quickest task which is happening at first. So that means instead of start time, we need to consider the end time. So whose end time is earlier than anyone in this list? So that means we would like to sort this list definitely, but based on the end time, not the start time. So if we just sort it accordingly, so the first task would be 1 3, because 3 is the value of end time, which is the list among this list. So the next one would be like 2 comma 4, because after that the 4 comes. And the next one is going to be the 3 comma 8, this value. And the next one is going to be 10 comma 11, right? So this is the converted list which is going to be fed into the algorithm. So the first is step, if we just say, that is going to be sort based on end time. And this is like sort in ascending order, right? So if we have this list, for an example, this list is available to us, what is the next step? So as we mentioned, that is very important point, that initially the solution is going to be the first activity. So if you take an array called solution, right? Next step we are talking about. So that solution will have the first element of this sorted array. That means 1 comma 3. Why? Because we have assumed that the shortest ending task will be considered the most quickest task can be performed by this single tasking machine. Naturally, sorry, whoever will be next will be based on 1 3. Whoever will be next will be based on who is placed on next on 1 3. So let's say, let's see and try to understand. So first is, if we consider 1 3 as our first task which will be performed by this single tasking machine, then the solution is having 1 3 right now. Okay, so you can say like we have loaded 1 3. So next we will check if the current activity which has been overloaded over here, or you can say like if the current activity overlaps with the upcoming picked activity. So for an example, 2 4, if we consider 2 4, this 2 4, this is the upcoming next activity in the sorted array which we have prepared. This 2 4 is having a clear intersection with 1 3, right? So we won't consider 2 4. We simply won't consider if like we have an overlap. So we can say if it is our current activity 1 3, so we can say car activity, if you can say like in this way, if car activity like overlaps So we are just writing the algo on a high level with the upcoming next activity, or with the, you can say, like, next activity. Then what is going to happen? We simply ignore it. We ignore that one. So 2 4 is having an overlapping with 1 3. So 2 4 is going to be ignored, right? But if it is not having that part, else add. So if it is not having, for example, 3 8 is not having any intersection with the, is not having any overlapping with the current activity, which is 1 3. So after adding that, our solution array is going to become like this: 1 comma 3 and, sorry, and 3 comma 8, right? So if it is the case, the next activity is 10 11. It is not having the overlap, so simply this first condition is not gonna work. So the next one is going to be 10 comma 11, right? So we have a solution array. So this 10 comma 11 is basically not having overlapping with 3 8. So every time we are changing our current activity, so whenever 1 3 was there only in the array, we are considering 1 3 is the current activity. So topmost activity is going to be the current activity. So the next one is 3 8. So that is going to be the current activity. So in this way, we will change our current activity. And that change in activity, we need to handle it programmatically, and we will compare with the upcoming next element whether it's having an overlapping or not. If it's not having an overlapping, we will simply add it. Is that clear? So yeah, how we can write it? First of all, we need to write a function. If we just say, and so this is like a array sort where we can make like some fine tuning during the sorting process, so that, I mean, why fine tuning? We can use some comparator class, and that comparator class will sort the array as far as our requirement, right? And we can pick two values. One is our result, which will be returned, and final number. So that is going to be returned one. So in this case, it is 3, as we can see that. Another one is like the current, right? So if we just try to write the function, I mean, activity function. So how can we say like get number of activity or get number of activity? Say, for example, if we just say like this, get number of activity, and try to see how the code will look like. So here, first of all, we can take like the array is going to be an input. We are writing pseudocode, definitely. So this is an input array, and we are taking a comparator. So that is written by us. So what we gonna do? Say, for example, if we just say in case of Java, arrays dot sort, and we give like our input array over here, there as an input, and this instance of mycomp, which we are basically, just a minute, let me think. So we can do one thing. So instead of writing this, we can take only one input, like activity should be the class, which will be having lot of activities. Like, so the array will be of type of activities. Okay. So in case of this, we would like to use some comparator over here during the time of sorting. We can pick two variables. One is our result. Initially, we can make result 1 because we are choosing the first short task which is being done so short, I mean, so early. Another one is previous, which is a pointer will responsible to take a track of previous part. Now, if we just take, for an example, a for loop, and within this for loop, ARR, and we keep an index called car, right? So if ARR.car.start, if we just say start, right? If it is greater than equals to ARR and previous dot finish. So if start and finish is basically two parameters, like this is start, this is finish. In that case, if the current start is greater than the finish start, okay. But actually, I made one mistake. This is basically the condition which should run within within the for loop. So the for loop should basically like the current. We can start current is equal to 1 because we have taken the first element as our, I mean, the first activity as our basic treatment for our basic treatment. And then we can say that it will go up to array length, and our current pointer we can increment over here. Sorry. Right? So within this for loop, what you can do, we can simply put this logic that if it is happening, that means we can say that we do not have any overlapping boss. So if we don't have any overlapping, that means we can wisely increment result. We are doing that. And if it is no overlapping, so that we can say we have added successfully a new item, and that new item will become the previous pointer. So because previous pointer is something which is going to be compared right here. We are comparing with the previous value. So the previous value spin is 1. So this is 8. And which is the current value? The current value is 10. So if it is not greater, then it doesn't have any overlapping. So that is exactly we are checking in this line, right? To check the overlapping part, right? But if it is not overlapped, that means we need to modify the previous pointer. So the previous pointer is going to be set as our current, because यहाँ पर जो current था वही तो previous हो गया ना, right? So if this if is getting closed, if the for loop for all elements gets closed, then we can simply return back the result, and that is something which we are looking for. So this is a simple, super simple pseudo code. So if we just revisit it, we have a list of an array. Sorry, we have a list of activities, and we are checking like whether they have any. If for every item, I mean, which resides in this activity array, we are checking whether we have an overlapping or not. If we have no overlapping, then we can increment our result variable. We started initially 1 because we have already assumed that the solution array is basically taking or considering the first shortest element of activity, or first shortest activity as an element. So that's why current is equal to 1. So we starts with 1. So that means we start with the second element, and we start comparing whether he has really got any overlapping or not. If it is not having no overlapping, then we can wisely increment the result variable, as well as we can change our pointer, which is the previous pointer, because that is being used to make the comparison, and the comparison decides whether we have overlapping or not. And finally, if everything goes up, done, then we can return the result. So that's it from my side. If you have any question or doubt, you can definitely put a comment over here. Thank you.